Okay, so this is our first tutorial. Uh, we will have a problem set. I'll share the
Good
problem.
afternoon.
I'll share the problem set with you now, and then you have to solve these problems here only. Okay. Next thing, if you have any doubt in any question, you can ask. Okay. So we start sequentially. So first problem first, second problem, then third problem, and so onwards. Okay. So I hope you are able to see this Jamboard. Okay, are you able to see the Jamboard?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Okay. So here is the problem set. So I hope everyone is able to see this.
Yes, sir.
Yeah. So you can just write down these questions 1 to 8. Okay. And then start solving from first to 8. Okay. If you have any doubt, any difficulty, I'm there to help you. So please write down these 8 questions first, then start solving. So I hope you are done with this. All of you have written these questions.
Yes, sir.
Sir, just a minute.
Okay. We're done with this. All of you
Yes,
have
sir,
written
done.
these questions. Yes. Okay. So now we can think of the answer of the first question. Anybody got eigenvalues of first?
Solving, sir.
Solving. Okay. Anybody got the values, eigenvalues? It's just a 2 by 2 matrix, so I don't think it should take more than 2 minutes to solve. What is the matrix we have? A is equal to so we can go with the example one. Let A is equal to, what is the matrix A we have? Minus 1, 4, minus 1, 4, 2, 1. Okay, so what will be having be the given matrix? Then what we have to do is consider characteristic equation of A. So what is the characteristic equation of A? Determinant of A minus lambda I is equal to 0. So we got here minus 1 minus lambda 4 2 1 minus lambda, and this is equal to 0. So what we got here? Minus 1 minus lambda into 1 minus lambda, and this term is minus 8 is equal to 0. Find out the product for this. Okay, so we can have minus 1, this is going to be minus lambda, this is minus minus plus lambda, you will be having, and then plus lambda square minus 8 is equal to 0. So we can get here, this is lambda square minus 9 is equal to 0. So what we got here, this is lambda square is equal to 9, and hence lambda is equal to plus or minus 3. How much time it took to solve this problem? So we got the eigenvalues of A are 3 minus 3. Okay, and now we have to think of the determinant of this. Okay, so consider determinant of A. What will be having here? -1, 4, 2, 1. And what is the value of determinant for this? So it is going to be -1, -8, and that's going to be -9. So we got determinant of A is equal to -9. See the question. What is the question? If A is this matrix, then we have to find the eigenvalues of this matrix. Okay. So what we will be having? We have the value of determinant A. Okay. So what we know is we have first, if lambda is eigenvalue of A, then determinant of A upon lambda is eigenvalue of adjoint of A. Then what the next we want? We can find eigenvalue of adjoint. Now A square. Okay. So what we know is if lambda is eigenvalue of A, then lambda raised to n is eigenvalue of A raised to n. And third, the eigenvalues of identity matrix are 1. Okay, so these are the three properties of eigenvalues, or these three comments of eigenvalues are going to help you here. Okay, so as we want the eigenvalues of this matrix, and hence what we can do is, so the eigenvalues of adjoint of A plus we have -3A square -3A square, and what is the polynomial? Plus 4i r. So what will happen here? For this first, lambda is equal to 3. So here the eigenvalue of adjoint corresponding to 3 is -9, determinant of A by 3, minus 3 into 3 square and plus 4 into 1. So this is the first eigenvalue we have. Then second eigenvalue, what will be having? -9, determinant of A by -3, -3 into -3 square and plus 4 into 1. Okay, so that is, now simplify what this eigenvalue is. So it is -3. This will be -27 and plus 4. And here what will be having? This is 3 -27 and plus 4. So we got here, that is, what will be this eigenvalue? So it will be -26. And what will be this eigenvalue? -20. So we can say the eigenvalues of adjoint of A minus 3A square plus 4i are -26 and -20. Okay, so this way we need to use the basic properties of eigenvalues, and we are able to get the eigenvalues of any polynomial. Okay, so how many of you got this answer? How many of you got this answer?
Got it, sir.
You got both the eigenvalues minus 26 and minus 20.
First one I got, second one is waiting. I was
Okay.
finding.
Okay. What about others?
Yes, about it.
Okay, that's good. So if you know the comments easily, you are able to get the eigenvalues of any polynomial or any function. And the comments are easiest way to get the eigenvalues of the function. So will you able to solve the second example? So those who are done with the first
Yes,
example
sir.
may go for the second one. You got answer? Anybody else? Naveen, you got answer?
Yes, sir.
Okay. So second problem will be able to solve?
Yes, sir.
Yes, sir.
Yes. Okay. So it is very similar to first one. Okay. Now consider the next. So what do we have in the next? Suppose we have a matrix A and then it has eigenvalues 5 and minus 1. And we are asked to find the eigenvalues of, we have to ask the find, we are asked to find the eigenvalues of x and y. So how do we are able to get the values of x and y if I know the eigenvalues of this matrix? So are you able to get the values of x and y? Any of you is able to get the value of x and y? What we have to do to get the value of x and y? Can you tell me? Aditya, Shetty, what we have to do to get the value of x and y? We know the eigenvalues of this matrix.
Sir, we will get the first characteristic equation, and by
Okay,
putting the values, we will get the values of x and y.
correct. So this is one way. That's good. Okay, is there any other way?
Sir, can't we use the sum of the diagonals and product of the diagonals?
Yes, we can use sum of the diagonal and product of the diagonal. We can use sum of the diagonal matrix as diagonal elements as the sum of the eigenvalues. That's true.
Yes, sir.
The second one is the product of the eigenvalues is what is
Product
the
of the diagonal.
No, it is not the product of the diagonal. It is determinant.
Yes, yes, sorry, sir. Determinant. Yes, sir.
Yes. Okay. So product of the eigenvalues is going to be determinant. Okay. So these two equations will be sufficient to get the values of two variables x and y. Okay. So there are two ways. One way is given by Naveen. The other way is given by Meenal. Okay. So when we consider the characteristic equation and then equate it with the given eigenvalues. Okay, so at that time we need to have the two equations into unknowns x and y, and then we are able to solve. We are able to get it. Good. So we can solve it. Correct. Let's try. So we can have the next example. Okay, 3. What we have here in 3, this is the matrix. A is equal to x 4x 2y. Okay, so let A is equal to x 4x 2y. Okay. Be the matrix with eigenvalues. What are the eigenvalues given for this matrix? It's going to be 5 and minus 1. Okay. So it is 5 and minus 1. Okay. So what we know is, since the sum of eigenvalues equal to the sum of diagonal elements of matrix. Okay, and hence we have, so what we'll be having, x plus y is equal to 5 minus 1. So we got here x plus y is equal to 4. Let this equation run. Also, what we know is the product of eigenvalues is equal to the determinant of matrix. Okay, so what we have here, hence consider determinant of A is equal to, so what will be the determinant? X 4x 2y. So this will be x into y minus, this term is going to be 8x, and we know this is equal to 5 into minus 1. Okay, what this term is going to be the product of eigenvalues equal to the determinant. So we got here x into y minus 8x equal to, it's going to be minus 5. Okay, so we got here x into y minus 8x is equal to 5 into minus 1. Okay, now what we have here, so we can write x y minus 8 is equal to minus 5. Let this equation 2. Okay, and what we have x plus y equal to 4. This is equation 1. So can we use the value of y or x from equation 1 in 2? Okay, so what we can do is we can put either you replace x or you replace y. Okay, so put x is equal to 4 minus y in equation 2.
Mama.
Okay,
Hello.
so what happened, Shivam?
नवीन म्यूट कर ले.
नवीन म्यूट कर.
What happened, Naveen? Okay. So if we put x is equal to 4 minus y from equation 1 in equation 2, so what we'll get here, this will be 4 minus y minus 8 is equal to minus 5. So this will be a quadratic equation which we can solve easily. So we can have this 4y minus y square minus minus plus 8y, and this term is equal to minus 5. Okay, so what you can write is minus y square, what this term is going to be, plus 12y is equal to minus 5. I can take this on the other hand side, and we can write here this is y square minus 12y minus 5 is equal to 0. Is that okay?
There is minus 32 is also there.
What will happen?
Minus 8 into 4.
Yes. So this term,
So 4 value should be there.
yeah, minus 32. So if I take minus 32 on the other hand side, what I'll be having here? Plus 32. Correct? So this is minus 32, right? Okay. Now see, what is the quadratic equation we got? Y square minus 12y and plus, what this term is going to be? 27 is equal to 0. So can we factorize this? Is that okay? Are you getting this factorization?
Yes, sir.
Okay. So we got here y is equal to minus 3 or y minus 3 into y minus 9 is equal to 0. So we can have y is equal to 3 or y is equal to 9. So now see, if y is equal to 3, what is x? See, x is 4 minus y. Okay, so x is 4 minus 3 and that is equal to 1. So we got x equal to 1. Okay, so when y is equal to 3, we got x is equal to 1. Now if y is equal to 9, okay, then we have x is equal to, what is the term here? So it is 4 minus 9. So we got here minus 5. And hence x is equal to minus 5. Okay. Now see, here we got the values of x and y. Okay. So this x and y has to satisfy equation 1. This x and y has to satisfy equation 2. Okay. So let us check which pair satisfies this both the equations. Okay. So we have the values of x and y as, so when x is 1, y is going to be 3, and when x is minus 5, y is going to be 9. Okay. So first equation, what is the first equation we have? X plus y is equal to 4. And you can see both this satisfy x plus y is equal to 4. Now check for the second equation. So x into y minus 8 is going to be minus 5. So this we are verifying now. Okay, so x into y minus s equal to y minus 8 is equal to minus 5. So we can have x into y minus 8. This has to be minus 5. This is the second equation. So if I use this, what I'll get? 1 into 3 minus 8. So we got 1 into minus 5, and that is minus 5. So it satisfies. Now think of the next pair. Okay, so if I consider this next pair, what we have? Minus 5 times y, 9 minus 8. So it is minus 5 times 1, and that is going to be minus 5. So both these pairs satisfy both the equations which, or both the conditions which we have, and hence both the pairs are the values of x and y when this matrix will have the eigenvalues 5 and minus 1. Yeah. So you got the answer for this question now. A simple technique that we have used, the sum of the eigenvalues and the product of the eigenvalues. So is there any doubt in this example?
No, sir.
No, sir.
Okay, that's good. What about the next question? So here we have the Calamilton theorem. So will you able to verify the Calamilton theorem?
Yes, sir.
Okay, so now the question is how to calculate A inverse and A raised to 4. Okay, so the question is how to calculate A inverse and A raised to 4 after verifying the Calamilton theorem. Okay, so I'll give you a hint for this problem. Okay, question number 4. Okay, so we know how to verify the Calamilton theorem. So the Calamilton theorem will you will able to get the characteristic equation, and then in the characteristic equation you will put lambda is equal to A and then you will show that the polynomial, characteristic polynomial comes out to be 0. So we can say yes, the characteristic equation is satisfied, and then you can say the Cayley-Hamilton theorem is verified. Okay, so we get, okay, what you will get is you will get a cube minus s1, okay, a square plus s2 a minus determinant of a times I is equal to 0. Okay, this will be your equation 2, because first equation is the characteristic equation you will calculate, and then you will prove that this is going to happen. Okay, so this is going to be your equation 2. Now what we can do is, if I want to calculate A inverse, multiply this by A inverse. So multiplying above equation by A inverse, we get, okay, see this determinant is going to be constant term. So that's why please be careful for this determinant term. It is going to be constant, S2 is constant, S1 is constant. And hence what I'll be having is A inverse A cube minus S1 A square plus S2A minus determinant of A into I is equal to 0. That's what we have. Now if you multiply by A inverse, what I'll get is A cube into A inverse minus S1 A square into A inverse plus S2 A into A inverse minus determinant of A inverse into I is equal to 0. So what we know is A into A inverse is equal to identity. So here you will get A square into identity minus S1 A into identity plus S2 times identity minus determinant of A times A inverse, and this is equal to 0. We are interested in this term A inverse. So what I can write is, I can take this on the other hand side. So we'll get determinant of A times A inverse is equal to, so what we'll get here, A square minus S1A plus S2I. Okay, and then take this, first calculate this matrix, what this matrix is going to be, and after calculating this matrix, you have to take this determinant on the other hand side. So you will be having A inverse is equal to 1 upon determinant of A into this matrix that you have calculated, A square minus S1 times A plus S2 times I. So this is your equation 3, which will be the A inverse. And now we want to calculate A raised to 4. So can any one of you tell me what we have to do if I want to calculate A raised to 4? If I know equation,
multiply the given characteristic equation by A.
correct, absolutely correct. So we have to multiply equation 2 by A. Okay, and then A raised to 4 we have to keep on one side, and then rest of all the terms on the other hand side. And you have A, you have A square, you have A cube, because you have used these values while verifying the Cayley-Hamilton theorem, and that's why these values are always available with you. So you just have to add and subtract these matrices. So I hope you will be able to do it. So will you be able to do it?
Yes, sir.
Yes, sir.
That's great. So what about equation 5? Reduce the matrix into diagonal form. So what we have to do in this problem? Can any of you tell me what we have to do in this problem?
First, we should find arithmetic.
Yes. What we have to do? First we have to find.
Algebraic multiplicity and geometric multiplicity we have to find first.
Yes. Before that, what we have to find out?
Characteristic equation and eigenvalues.
Eigenvalues.
Yes.
and eigenvector.
So first task is always to find the eigenvalues and eigenvectors. Okay, only in case of Cayley-Hamilton theorem we don't have to find out the eigenvalue and eigenvectors. Okay, because Cayley-Hamilton theorem deals with the characteristic equation and not the characteristic roots. Okay, so when there is a question of Cayley-Hamilton theorem, we don't have to find the eigenvalue and eigenvectors, but otherwise we have to find out the eigenvalues and eigenvectors. So in this case, okay, first we have to find the eigenvalues and eigenvectors, and once you know the eigenvalues and eigenvectors, then we can compare their algebraic multiplicity and geometric multiplicity. So what will be the conclusion and how will conclude? How will get the diagonal form?
By finding the arithmetic and geometric multiplicity.
So if you place the eigenvalues on the diagonal of a matrix, then it is the diagonal form of the given matrix. Okay, but this matrix may be or may not be diagonalizable. Okay, this matrix may be or may not be diagonalizable. Okay, means possible that we are having the eigenvalues, but we will not able to find out the model matrix. Okay, and at that time we can just write D is equal to, but without writing M. Okay, so we are not able to find M, so we do not write M, but we can always write D, the diagonal matrix, which is the diagonal form of the given matrix. Okay. So will you able to write the answer? Anam, will you able to write the answer now? Almisan,
Yes, sir. Yes, sir.
will you able to write the answer? Almisan, Alimisan. Okay, that's good. You will able to write the answer. Okay. Nyanshu. Nyanshu.
Yes, sir.
Will you able to write the answer?
No, sir, I couldn't, sir. I got a
Okay.
wrong answer.
Yes. What we have to do exactly? We have to find out the eigenvalues. We have to find out the eigenvectors. Okay. And then what we have to do is we have to compare the algebraic multiplicity and geometric multiplicity of these eigenvalues. Okay. And if the algebraic multiplicity and geometric multiplicity is the same, then we can say the matrix is diagonalizable, and we will able to write the model matrix M also. Okay, but if we are not able to write the model matrix, then at least we are able to write the diagonal matrix D. So the diagonal matrix D is consisting of the eigenvalues of the matrix A on diagonals. So will you able to write Nyanshu now?
Yes, sir.
Okay, that's good. Okay, Prachati, will you able to write answer?
Yes, sir.
Okay, that's good. Okay, now we can have the sixth question as find eigenvalues and eigenvectors. Seventh question, show that the matrix is diagonalizable. So 5, 6, and 7 are very similar. You just have to find out the eigenvalue and eigenvectors, and then for diagonalizability, we have to find the algebraic multiplicity and geometric multiplicity. Okay, what about the 8th question? What we have to do in the 8th question?
Smaller the system, like simplifying using Cayley-Hampton theorem.
Yes, Naveen. Which is the tool that we have to use to solve the last question?
Cayley-Hamilton theorem.
That's good. Yeah, we have to use Cayley-Hamilton theorem. But here, you don't have to verify the Cayley-Hamilton theorem, because directly it is asked that find the matrix represented by this polynomial. Okay, so you can say directly that by Cayley-Hamilton theorem, the polynomial you can write directly equal to 0 and use that polynomial to divide the given polynomial. So our miniaturized system will be nothing but the remainder. Okay, so our target is nothing but the remainder. So our target is to find out what is remainder after dividing the given polynomial by the characteristic polynomial of the matrix. Aditya, will you able to write the answer? Aditya Shetty.
Yes, sir.
Okay. Minal,
Yes, sir.
Kunj, will you able to write the answer?
Yes, sir.
Okay, that's good. Okay, so please write all the answers properly. Okay, whatever the points we have discussed, use that points to solve, write the answers properly, and you have to upload your tutorial in week 3. I hope you are all accessing LMS. Okay, so access LMS, and in week 3 you will find the assignment 1. So there you have to upload your tutorial, all the solution. You have to mention your roll number on each page. Okay, your name on each page. So please write your name on each page, write your roll number on each page, and then you have to upload a single PDF file. Is that okay? So will you able to do it?
Yes, sir.
Yes, sir.
That's good.